Is software slower today? Let's hear some superstar developer what was saying. So let's hear Jonathan Blow.
So, do we see other things on the screen? Yes, we do. So, suppose during my regular game development everyday life, I'm doing stuff like I've got a screenshot. I've installed Photoshop recently and I want to look at a screenshot of the game. Someone reported a problem or something. So I double click on the thing. 1, 2, 3, 4, 5, 6. It's about 7 seconds before I can actually see the image, right? And I'm a very sad person because I installed Photoshop, which for some reason was presumptuous enough to make it be the default handler for this image type, and I have to go like change that, and I grumble to myself and stuff. So that's really slow, and I'm going to talk about that for a bit. But there's an element of severe irony to this, which is that as soon as I double-click this thing, within 1 second, it draws an image, right? And it's a pretty high-resolution, interesting image. It's just not the image that I care about, right? So obviously, it's not hard to like start a process and draw an image on the screen in much less than 7 seconds.
Okay, and let's see how it continues.
It's a fast SSD, but yeah. Now, my whole point is that it's not just Photoshop that has this problem. All modern software has this problem, right? Compilers are all really slow. Text editors are really slow. Operating system UIs, all the little windows that pop up, are frustratingly slow. Often, websites are really, really, really slow.
Okay, so let's unpack it. So these are the claims. I will put the clip in the description. And let's go some caveats. Even I fully disagree with Jonathan Blow. He is definitely a veteran software developer. He is 25 years plus developer. I am kind of 15. And let's put some parts which I think we should agree that they are slower. So for example, just to open a file and read the line, what is contained in that file. In the DOS era, like before Windows, basically, in 1990s or 80s, there was basically you will look into a tree structure, which was the file system, and when you had access to the file, you would basically jump where the file starts and you read, and there were very little permissions on top, like read only, if I remember right, archive. And with NTFS, you have all these permissions of before, but you have a file system which is keeps integrity all the time. It has a journal, and also what's more aggravating, for example, that Windows enables also antivirus. So to open a file, typically an antivirus will intercept that call to check to make sure it's not a virus. Then it will let you read that file. So in this way, yes, software is slower. We can see more examples like this. So for example, when you use something like routing, and I can say because I'm working in this kind of field, there is a special service in Windows services that does just routing. And what it translates to is that if you have you or Microsoft, when implements, they have a bug in routing, it will not block all internet access. It will, something which is named NAT, network address translation, may not work, but you can still connect and do whatever you want with your work. Similarly, there are parts which are moved out from Windows kernel, like the graphic drivers, and this improves hugely the stability of your system. And there are many parts like this that they look bloated and they do much more. Earlier I talked about Windows Defender, there is Updater, WinS6S, we can talk Windows on Windows and more, but the thing is the same theme. And also today we can all agree, even we are for or against that take, that we have a lot of things which are slower in the way they are coded today. So even people don't know what functional programming is. This is a popular style of coding, and sometimes it's slower than a non-functional style of coding, but it increases a lot the robustness, thread safety, and it consumes more memory. But obviously, if you have a banking application, you'll want to be robust, or many types of software. You'll want to be firstly robust, then the ultimate speed. Obviously, you'll want people to optimize, but maybe it's not the part to optimize for. Similarly, today, if you use like a Word document, in the very old version, they were using a binary format. Right now, they are using a plain XML, which is much easier to read. And this is true both for Microsoft Office and LibreOffice or Google Docs. So you can use other tools to read it. And at last, in general, we work with more abstractions. We code most of the times with higher level languages today, like Java, JavaScript, C#. We don't code directly the hardware. We use high level APIs, so like DirectX. We very often, when we print something, we generate a PDF, and the PDF, it's also very important to have it as a PDF because you can also attach it to an email if the software requires, and so on. The other part which we should take into consideration is that very often the story is mixed. So for the sake of argument is that today's practices in software are tuned for the today's hardware, which is reasonable. So you code differently if you know you have an SSD versus you have a spinning disk. But more common is like if you want to go to the edge of performance, like doing games, even on the video card vendors, sometimes they don't optimize a few things. So your software may run unoptimal, and writing in the old style of coding, which Mr. Blow was recommending, is not true. Like if you'll code in a DirectX 9 style, your code will definitely work slower than a DirectX 12 code. And also it will be a cost of emulation in some drivers. Another part you should think is that sometimes when you think that all software is faster or the old coding is faster, is that some of the old software didn't solve any real concerns, or when they solved them, they would solve them in a wrong way. The simplest example I can think of is that the main function which we allocate in C, malloc, is not thread safe by default in very old Microsoft C compiler. So I'm not sure that Visual Studio 6.0 malloc function will not have a thread safe version of it. So this will mean that if you allocate in 2 threads, you will corrupt your memory, and it's very tough to fix it, especially as it happens in the race condition way. And this part is fully fixed. Even though it may work slower, at least it doesn't crash. All the software typically will not have a bounce checked versions of the C method, like strcpi, string copy, would not have a string n copy, so it was very unsecure. And also, if you were coding like in the old style directly, sometimes some interfaces are dropped by vendors or by libraries, and I can think of the Voodoo cards or adlib32 or something like that, which no one kind of supports, and you have broken software. And if it was coded for an abstraction, even you'll have a performance hit, that abstraction would work properly today, and the broken software is more than useless, even though it was fast in Windows 98 times or DOS era. But the part that may surprise most is that today's software in general is much faster. And let's go with the Photoshop example. So the Photoshop example is clearly a misunderstanding of Mr. Blow how it starts. So the splash screen starts fast because it has all the DLLs of the splash screen around. And after they are loaded, like the operating system, after that Photoshop initializes all the plugins, the functionality, and instantiates with that picture. But to show a splash, the single part it has to do, it has to get some libraries, mostly an image decoder, which probably it was used at least once, so it's warm in memory, and some drawing of a window, which again, it was already loaded in memory. All you have to do is just to decode the image and show it with some text. And again, all these things are loaded in memory. And then the dozen seconds or whatever, 7 seconds to start is only loading plugins and so on. And I know this because I'm working in these types of software forever and ever. But seeing is believing, and let's see if we can investigate, and we will use 2 programs to show it off. One is Paint.net and the other one is GIMP. So let's try to use GIMP. GIMP, I will use it instead of Photoshop. And you can see here some text. Right away the splash appears kind of after 1.5 seconds. And then you can see the image after 3 or 4. So why it's kind of the same 7 seconds, minus it's a bit different version. And why it is 1 second till the splash starts, not instantly. And the reason is the same, like GTK needs to load. These are the DLLs. And after they are loaded, the picture could be loaded. And at the end, the instantiating of the plugin, it's happening. On a similar note, this will happen with other image editor. So if you open with Paint.net, the same thing happens, only that Paint.net will start a bit faster because it has much fewer functionality. And excluding that, there is nothing abnormal of either of them. And some people will still say, but the old Photoshop was faster, and I'm sure it's not true. And I will use for that this test only Paint.net, but this is true for both. So I will put a gradient, for example, and I'll pick 2 colors for it. And if you put a gradient, you see nothing is abnormal on this kind of largish image. But what is the most interesting part is that if you go to Performance tab and you draw a gradient, you will see, I'm just dragging the mouse, that it uses all the CPUs, all the 8 cores. And this is true, I'm certain, for Photoshop, and it was not true for the old versions, because people optimize software for the actual hardware. Also, it's quite interesting that it was claimed that things like web pages are slower, and this is plain false. So in JavaScript runs at least 100 times faster on the same kind of page than whatever JavaScript engines were around year 2000. Pages are GPU accelerated, so even if you don't have a 4K screen today, this means more or less 8 million points of data, and it is painful if you run them on CPU. The JavaScript is even faster if you work with type arrays and ESM.js or WebAssembly. And the single part which I think it would be slower, technically, it would be if you run a CPU which it's very weak to decode HTTPS as being the encryption standard. And again, we want encryption because you not want everyone to listen to your connection, or anyone in fact. So this is what is the warranty of HTTPS, that you trust some authority to encrypt properly your web pages, so there is no man in the middle. Also, to me, it was quite interesting to say that compilers and text editors are getting slower, because I don't know what he means. Maybe he means that Visual Studio gets slower because it has many more plugins, and it starts slow like Photoshop because it starts many plugins. But in general, I know many IDEs or things like that which they go faster, and even Visual Studio, it's faster. The latest release, it's definitely faster on large projects than the 2019 version. And also, I heard that compilers are slower. Is it so? Let's test it. So for this test, I would use GCC, but this would be true also for Visual Studio. And here, as a point of comparison, I'm using dev C++, which would embed the version from 2015 of GCC, which provides a C++ compiler, and Embarcadero having the same dev CPP but with the 2021 part. And I don't know a better example to use, but to use as like for like, and I found a prime numbers calculator, and this prime numbers calculator right away it says there is an error, and the reason is that we have to choose language standard C++ 11 because the old compilers were not supported by default. Let's choose it. It gives another error saying it's not a literal type, and I think it's because of this context. So let's build it again. So this is some code which provides it calculates the numbers of primes till whatever number, till a limit, and they will iterate a numbers of times. And let's see how well it runs. And to compile it took 3.3 seconds, 3.27. So let's run it. And it will look for 5 seconds. And the score is 1,600 iterations. And I know, because I tested it before, we can speed up by something quite significant, and we pick optimization level, and the best it's all fast. And okay, let's do it with all fast. So we'll do a rebuild all. This time it's a bit faster because few things are cached, 1.3 seconds. And let's see how fast it goes. And not sure if you can see, 3,400 iterations. So this is the code to calculate primes. And let's take the same code, and this is the project. This is it says it's an old format. That's fine. We know it's an old format. And let's put back context because this was the original GitHub project to do it. Then let's see if we have similar options of compilation, code generation, compilation level high. Okay, so high is not the highest, so it has chosen a bit weaker optimization level, but I'm fine with that. I assume with my limited testing that okay, compile log, I'm curious that compilation time. So 3.36. So first time it kind of compiled 3% or something like that slower. So 100 units of time versus 103. This could be also limited by turbo, but let's run it. So, and here are the 5 iterations. And look at that. This is 12,000 iterations to do the same algorithm. So the compiler, at least in this specific test could generate code around over 4 times faster. And for 3% of extra compile time every day, I would choose the, let's say, slower compiler. And we didn't choose O fast, but I think it will not change by much. But I wanted to put just for completeness. So let's calculate prime numbers. And I hope the turbo or recording would not change. No, so it's kind of the same, 12,200. So let's wrap up. So realistically, software is typically faster. And why? It is that the software, if it's not changed at all, it will run the same. But if the software is maintained, it will use by default new ways architecture are made today. So more likely, for example, if you compare with old versions of Photoshop, the newer versions of Photoshop use better multi-core, they use better the GPU, they use better some other instructions like SIMD. Also, I don't know if you are a software developer, but many software engineers, they like optimizing. They will not probably like to optimize every bit of data because you need to maintain it and so on. But if you say this part is slow and annoying users, most software engineers will fix it. And also, at last, please be mindful that if you think in my old times and you start XP and why XP works so fast and why not Windows 11, Windows 11 does many things more and better. And some people may say no, but start Task Manager. And you may say I use Task Manager just to kill a process, but the Task Manager in Windows 11 or 8 or something, because they were started, it is very granular and you can know what kills what. So for example, you could have in Windows XP one process that would use 2% or 3% of CPU, but in fact it will kill your disk. It will read and write disk, and it will make your machine not usable. And right now, even that task manager, let's say, will start slower or will use some CPU power. It will give to you the feedback to know what process to kill because it stops your application. And enjoy the really very prosperous times which we are on today. So that's it. I hope you liked, and if you like, please share the love and subscribe. Bye bye.